Watch, I'm gonna lose that subscriber, and then I gotta change my whole little joke. All right, we are started. Let's bring it back. This is the warm-up. The first step for this is to figure out what is the base for my exponential form. We're going to go from exponential form to log form. So what is my base here? What's my base?
10.
10. Good. Base, exponent, right? I know my base goes here. I know my exponent goes here because when we use the log, we're finding the exponent. Remember we did 10 to the x and we were trying to find 57? We worked really hard, and then you could just do log of 57 to find the exponent. So the exponent is what you're finding with the log. That's why it's over on the right side. So 10, x to the exponent, I put this one in last. And then if you just put log of 550, you're going to get what our exponent's equal to. Remember that our calculators do not have the base included because 10 is the common base. 10 is the standard. So you'll just push the log button. So maybe if you have your phone out, log button, and then 550. And that's going to give us our exponent of, what'd you have, man?
Yeah, 2.74036.269.
That's pretty accurate. So if you put 10 raised to this power, you're going to get 550. That's who we studied yesterday. It's a way to figure out, instead of having to put in numbers, you put in a 2.7, you get close. You put in 2.74, you get closer. But to go right to finding that exponent, log of 550, that gives us our exponent. That's the functionality of the logs. Okay. Who missed yesterday? Raise your hand, please. Who missed yesterday? Same group was here yesterday. Interesting. Okay. All right. Then let's go ahead and get out a piece of paper wherever we're taking notes. I'll pause this. Here we go. All right. The key to this is that my bases have to match. In order to be able to do these processes, the bases have to match. We already know some of these things from the exponent rules we did Monday. Okay. Now, same rules as the exponent. So I look at number 1, the addition. And if I think about this, essentially it's x squared times x to the third. What's that going to end up being? Xx, xxx, times. What do they give us? X to the fifth. If we add all these up, we have 5. So what is the rule that we can do with the exponents? The rule is we can add them. Okay, it's the same rules. I'm just pointing that out. It's the same rules. Now we're dealing with logs, though. So if log, your problems when you get to the classwork are going to look like this. You know, it's going to have log of 6 times 12. And you're supposed to deal with these as separate entries where it's going to be, here's our m, here's our n. So what would I do if it's log of m and n? M and n. That's not right. Log of m times n is equal to log base b of m plus log base b of n. So how would I rewrite this? I'd rewrite this as log of 6 plus log of 12. You see, it's just going between the identities. We're just practicing right now the 4 properties. The main 2 are subtraction, addition. Then we have one that's exponent, which essentially just takes whatever the exponent is here, brings out in front. Okay. This is the base match. When you have a base match, log base b of b, it equals 1. So we get to cancel those out. Okay. Those are our 4 that we're dealing with today. So the first step is, let's look at example A here. And with your neighbor, I want you to tell me what 2 properties, which of our 2 properties are going to be included in this in order for us to move to the next step. So talk to your neighbor real quick. What do you see and what are your hints? What do you see? Again, so we're looking at how this pattern right here, this problem, matches one of these. It doesn't have division, no fraction, so I know it's not subtraction property.
Yeah.
It doesn't have multiplication, right? So work it that way. All right, everyone talk to one person. Everyone talk to one person.
Yeah. What are you listening to?
Oh, I was there. Okay, I finished my base so fast.
Alright. Don't get in too long of a combo about that. Alright, here we go back. Whoops. People at home were like, what happened? Alright, somebody give me the first property. What's the first property we're going to deal with? Raise your hand. Give it to me. What do you say? Haley.
Exponent.
Exponent property. We're going to have an exponent. And that's because I see that, just like in this case, log base b of n raised to the k. This is log base 10 of 10 raised to the 2. So that's one of my exponents. Who has the other one? Raise your hand if you got it. Malaysia.
Base match.
Base match. Base match is something that I call it. Here's our base match. You could, I mean, the matches, the bases match. It's just base match. So let's go ahead and deal with it then. What happens to this 2? I'm going to rewrite this, and where's the 2 going to go? Log base 10 of 10. Where does the 2 end up if I follow this rule right here? In front. 2. Okay. And then the base match was the other. We just did the exponent. So let's do the base match. What's going to happen with the base match here? What happens to my log base 10 of 10? 1. This cancels out, becomes 1. So I have answer of 2. That's my answer. You see how we do this? It's kind of, you just have to get used to it. That's why I say when we get to classwork, actually, because we'll have a lot of time for classwork, I want you to get through all of them so we get a lot of experience today for that. What's the crux? I think I have like three pieces of candy after the sub yesterday. I'll give Candy Crux if you got it. The sub ate all my candy. I'll find you. Yeah.
Mr. T.
With, like, you have to move the exponent.
This part, we have to move the 2 out in front. Okay, that's one crux. Okay, and I think that was like the main crux. You're like, well, what comes next? What's another idea there?
I was thinking like the log and the base.
Base 10 of 10.
Yeah, and like to remember to cross it out if it matches.
Cross it out. Crossing it out, maybe instead you circle it. You circle it anytime you have base match. You know it's going to turn into 1. Because even when you cross, you're like, do I cross the 10s and then the logs left? Do I leave the 10s? So circle it, that whole thing is going to become 1. Makes sense? All right. There's only 4 of us, 4 of these to deal with, so we'll do a little practice for each. I'm going to go ahead and write a little larger than that. Let's look at example B here. B here. Log base 10 x divided by y. All of that is being squared. All right, we got 2 properties. Talk with your neighbor. Go ahead and tell me, what are my properties I'm dealing with here? You guys already see it. I don't even need to give you time. Good. Need a little more light. This one. Actually, Haley, just pull yours over like Twitter.
Oh, I saw that. The first one, let me have that 2. Let me see.
Step on the way out. Okay, I'm going to cold call somebody, so talk to their neighbor. Make sure you have at least an idea. 2 brains can figure this out for sure. All right. Silence out goes across the class. Let's see, Melissa, what do you say?
2 and 3.
Name them.
Subtraction.
Subtraction.
And then also
Exponent. Right? Here's my exponent. The fraction tells me that there's subtraction going to, come about. Okay. First thing though, because this exponent is applied to this entire fraction, I say we deal with the exponent first. Deal with the exponent first. So go ahead and go to the next step. Where is that 2 going to end up? I'll just write the log base 10 like this. You tell me where things are going to end up. Where's that 2 going to end up? Let's see. Yeah. Out front, right? Good. This 2 goes here. We're still with x and y. And I also want to point out that this 2 was applied to the entire expression here. So I also want you to do this. We are, whatever happens inside these parentheses, 2 is going to be outside and we're going to leave it outside. Because we're simplifying, we aren't going to distribute. We always want to factor everything out we can. So let's go ahead and make a little room. Melissa said it was going to be subtraction. So I want you to put what goes here. What goes here? Log base 10 of x divided by y. Right? Because division, log base of a fraction, splits them up. Log base b of n minus log base b of n. See? This is really just reorganizing the info. We didn't prove them in here, but we're going to trust the 4 rules always work. All right, let's see. Estefania, what do you think? What goes here? Perfect. All right, Julia, what goes here? Close, you got it. You got it. X over y was here, and now we're going from this step, interpreting the fraction, into 2 expressions that are subtracted. Because it's division, we subtract them. So log base 10 up. What? Remember that on the calculator there's no log base 10, because log base 10 is the common log. So I want you to just note that this right here is correct and no different than that. Log x is log base 10 of x. It's the common, it's the main thing. It's relatable like this. If we have the second root, we don't put a 2 in there, right? Because the root's definition, the first root is the second root. In the same way, similarly, log base 10, since it's the first and main common base, you'll see it without it on the classwork, and don't be fooled. It's log base 10. They just don't put it. All right. Have a good meet.
Hi, Max.
All right. Give me a thumbs up, sideways, down for this so far. Show me. All right. Okay. Good. Does anyone have a specific Candy Crux for why? What is the challenging part with this one? Yes.
Think that it's when you said the exponent, you have to remember it's applied to the whole thing, so you have to separate the 2 from the rest of the expression.
Yes. And when we get to example D, you'll see the opposite option. So. All right. So we just did example B. We're going to go ahead and cross that one out. I just did it on the other board. Here, what are the 2? Someone's a loud whisperer. Jeez. Everyone in the school just said that. That's some high quality whistling.
Whistle back and then
You didn't look. I'm not as powerful with whistling. Max was over here. I thought it was going this way. This is all very important to logarithms. I'm glad I broke for that. That's fine. Keep things light. What are my 2 properties I see up here? Anybody? Give me one. You got it.
Wait, never mind.
Not quite. Haley. We see subtraction. We see subtraction here, so I know I'm going to convert it back to the other option. What else do you see? We see exponent. Because I know this 3 was the exponent of that first term. Okay. Let's deal with the exponent first. I want you to deal with the exponent first, and remember that the 3 is only applied to this first term. So I want you to transition the other direction. When the number's out front, we can apply it to log base b of n over here. So the next step here is we're going to move this 3. I'm going to still end up with log base 10 of x. I'm still going to have this log base 10 of 4 over here. But what happened to this 3? Go ahead and put it in its new home and check with your neighbor to see that they know where it goes. Where's it go? All right. Z, where's it go?
Above the x.
It's log base 10 of x to the third power. Okay. So I know that since it's subtraction going on here, I know I'm going to end up with log base 10 of some fraction. We're just going the other direction now. We subtracted the two. Subtraction property tells us that we can get into this form as well. These go back and forth. You can go back and forth. You know it. Right. Who feels like they know it? Yeah? Not sure? Not sure. Not sure yet. Okay. So the two things that are going to end up in the fraction are x to the third and 4. Which one goes on top, Melissa? X to the third power. What goes on the bottom? 4. Yeah. It would if we started with this problem. And this is actually really important. There's 2 problems on the homework that kind of go over this difference. If the problem started like that, then we'd end up with the whole expression here, this fraction, and on the outside would be a 3. But I look closely and I see that that 3 only applied to the first term. Thus, that exponent only applies to the x. You see it now? Subtle difference. Numbers 3 and 5, maybe make a note. Numbers 3 and 5 have that difference. And I want you to do numbers 3 and 5 in the classwork differently. Make sure you see that difference. And we're going to see it again up here, so don't worry about it. Okay. Okay. We're getting there. We're getting there. So, let's do the last one. Let's do the last one here. And yeah, this class has a lot of classwork because I want you to be able to do all of them to get the hang of it. Log x over y to the 5th. All right, with a partner, figure out what are the 2 properties that we're going to use. Find the properties. You're probably getting quicker at it.
Oh wait, no. Oh yeah. Oh yeah, now I see that.
X over y to the 5th. So so then you would use subtraction.
All right, if you haven't talked to anybody, double check. Make sure that you are getting some input.
You gotta choose one of them.
Well, there are 2.
No, I meant between subtraction and addition.
Don't pick addiction. Definitely pick subtraction. No, I think I actually said that. Some word came out weird.
You know,
All right. I'm going to ask, let's see. How about Nat B? Help me out. Give me one of the properties. Perfect. It's in a fraction, so I know we're talking about subtraction. That's perfect. All right. Let's see. Justin, how about the other property? Exponent. I know it's an exponent because, hey, it has an exponent. Okay. So in this case, let's deal with the subtraction first because that exponent is applied just to the y and is a little harder to express if I try to deal with the exponent property first here. That's kind of like you got to just have a little analysis on which is easier to start with. But I see that this is locked in, that's locked in, so let's go ahead and separate them. I'm going to have log and a log. I know that it's subtraction, so I want you to put what goes in here. What else is missing? What else is missing compared to our other problems? The 10. Is it okay? Okay. If I have base 10 or I don't have base 10 shown, I know it's representing base 10 right there because that's the common base. 10 is the common, the go-to. All right. So we're just filling in what goes here and there. But fill it in. I think by this point we should be getting close. Getting close to mastering this level. And there's another level next week. All right. Wazine, what goes in the first box? X. Anton, what goes in the second box?
Y to the 5th.
Perfect. All right. What other property do we have to deal with before we can say we're done? Yeah. Exponent. The exponent's still there. So Vanessa, what am I going to do with that 5?
You put it out.
Down front. This term here becomes log 5 log of y, and we had the log of x here. Now, why didn't I put it outside here?
Because it only applies to the y.
Only applies to the y. Only applies to the y, and the y is going to be defined and transformed into its own term, so that's why the 5 only goes with the y. That's as far as it gets for the classroom. Yeah, question? Got it now?
You got it.
Okay, okay. How about anybody else? You guys want a real challenge problem? Like, see if we can do it?
Yes.
Yeah.
I'm always good.
Hey, got it. You got
You're
it.
making us look bad.
It's a
It's a
lot.
rock set. It's glitching.
Watching from the beach.
All right, how about this one?
From the bodega.
Oh, okay. I think about this one for a second.
Oh my god.
I'm sorry.
PE. Yo.
Whoa, there's your D. Hey, whoa.
Hey, whoa, whoa. Hey,
It's really
Subtraction.
what do you see? I see the property of subtraction.
I see a difficult problem.
I see property of difficult. That's not property.
Subtraction is.
I see subtraction, addition, and a bunch of exponents.
This is
You can do it.
Zarash just said to give us a hard one.
Oh, you're done.
Wow,
You're done.
Rasha, I think you're all
Whoa,
bad.
what?
Just kidding. You guys don't know natural log yet. You don't know natural log yet.
Natural one.
Yeah, I know. See, I don't want to give it to you if you don't know. Natural log. We just got done with this. This one's like where there's like a world inside of a world.
I'm confuzzled.
Inside of a world.
I'm
Confuzzled. What teacher says that a lot?
I did.
Says what a lot.
Confuzzled? You didn't catch that up. You didn't pick that up from a teacher? It's been said multiple times in here. Have you been trying to pass on that word, make it like a... Yes? You got it?
You told me that.
There's one
I think I got it.
that applies to all of it. The other exponents are tied in with their own.
Mr. P.
With
Mr.
their
P.
own.
I think I got it. I don't think I got it.
I got it.
Not quite.
What is
Not
yours?
quite.
What's yours? Oh my gosh, Mr. P.
I don't think I got it.
I think I got it.
See, I like Italian food, and then Mexican.
Almost. It's very close. The sign's wrong, and we won't have a fraction.
And then, oh, what's the last one?
Good one. Yeah, they got it.
Send me the picture.
Told you I
That's
got
it?
it. Told you I got it.
Oh, this
Come
one.
here, but stop playing.
Hey, yo, told you I got it. Kaylee, I'm gonna need it. Okay. So,
That's two, right?
two, parentheses, two, log, plus 3 log y, minus log. This is me the picture. I'm
Explain what you got.
Do you know what
This
that
is
is?
D.
D.
It's like
See, oh, you had all, but you forgot.
Even so it's the log of this, so it's minus.
What have you been eating?
Everything's converted to logs.
I did it, I found my cue.
All right, I wanna show you guys this. Bring it back. What is the exponent that applies to everything?
2.
This one, right? This one here. Okay. So it's going to be 2 out front. Now, I have addition and subtraction properties going on. The addition is going to be these two that are multiplied together. We're going to end up with log, actually, 2 log x. Right? That's just this part right here. The 2 of this exponent is applied to the 2 log x. So this term is 2 log x plus 3 log y. The 3 is only applied to the y, so it's 3 log I. What's the last one? Minus. If you put a division symbol, remember that when we're converting between, it is divided by. So we're going to keep going with this. And Andy, what is it? Log what?
Z.
Log z. Ain't so bad. You won't have to paste that like that, but you see why it was the minus? Okay. So, Haley, let's see, Kit Kat, Reese's, or Kit Kat?
Cat.
Good choice. Perfect. All right, good job, y'all. Good job to all those viewers in Brazil. Ciao. Yes.